In the first movie, we saw how we were going to use the raw data from an experiment, which gives us the rate of responding in different outcomes of the experiment. So these are correct identifications, these are erroneous identifications, these are erroneous exclusions, and these are correct exclusions. And we saw that we could look at those response rates for both trials in which subjects were not allowed to use the inconclusive responses, and then trials where the subjects were allowed to use the inconclusive responses. And we saw that allowing the inconclusive responses reduced a lot of errors. So the erroneous identifications went from 165 down to 49, but we also saw that the correct identifications drops from 242 to 91. So we were thinking about how we can judge which of these two policies is better, given that both the good things and the bad things get reduced when you allow people to make inconclusive responses. And it turns out that we can judge which of these two are better, but in order to do that, we need to use some values that we derive from society to place values or weights on each of these outcomes. And so we developed an initial set of values just to get started that use a 1 here just to set the scale, and then we have a -10 for the erroneous identifications because that is a very bad error that puts an innocent person in jail, and we thought that that was 10 times worse than an erroneous exclusion. You can imagine it being more so, but for now that's the values that we have. We also give you a certain amount of value for correct exclusions, maybe not as much as correct identifications because it doesn't solve a crime. And then we gave this sort of smallish but non-zero weight for inconclusive with the suggestion that inconclusives, there is some value, some modest value that's derived from this. Okay. We're also going to need to know how likely are we to find a mated print during a comparison. And I put this number at 0.2 based on some discussions with some latent print examiners who claim that in their laboratories about 80% of the comparisons result in an exclusion. Part of this might be erroneous exclusions, but I think most of it reflects the fact that there are 6 billion people in the world who don't match this particular print, and there's one guy that does. And so even though the investigators have sometimes found the correct person, a lot of times it's going to be prints from unconnected people, or it's going to be the victim's prints, and so most of the time the comparison results in an exclusion, and so about 20% of the time I think you find an identification. We can investigate varying that value as well. Okay, the next thing I'm going to do here is I'm just going to copy these values, and I'm going to copy them in Excel, and then I'm going to paste here, and I'm going to paste special. I'm just going to paste the values here because the formulas will come along and otherwise. So here we have just the numbers, the frequencies at which subjects responded in each of these two conditions. Okay, so how are we going to use these values here in conjunctions with the rate at which subjects responded in each of these categories? Well, you can think of these as percentages for a moment. So think about 52 times out of 100 subjects made a correct identification, and 35 times out of 100 they made a erroneous identification. So of course these two things don't have anything to do directly with each other. These do, they of course have to sum to 1, and these of course have to sum to 1 because that's the total number of trials that were in the non-mated category. So you can think of these 52 out of 100. Each time you make a correct decision here, you get 1 point right here. Likewise, for every 35 times out of 100, you get -10 points. You get scolded 10 times, or you get scolded, a very bad scold, worth -10 points for every 35 times out of 100. So we can actually compute the total score that you would get for all the positive points you get and all the negative points that you get. In fact, first we're going to consider just the mated prints. So let's do that right here. We're going to consider the two SOPs. So here's SOP1 where you don't allow inconclusive responses, and then here's SOP2 where we do allow inconclusive responses. So in SOP1 for the mated prints, we know that 52 times out of 100 you made a correct identification, and each one of those was worth 1 point. And so we can multiply those two to compute the total points that you get, and it's about 52.517. Likewise, we can say that 48 times out of 100 you made an erroneous exclusion, or the subjects did in this experiment, and therefore each one of those is worth -1 points. And so when we multiply those together, we get the utility for each of these two responses, given the values and given the proportion of times that they occur. And then if we sum these up, we get the overall utility for mated prints for SOP1. And that overall utility is pretty close to 0 here, because the number of correct decisions is about equal to the number of incorrect decisions, and they're weighted equally. Okay, so now we can do the same thing over here for SOP2, where you allow inconclusives, and we compute the number of points that you get from correct identifications, the number of negative points you get from erroneous exclusions, and then here we actually have this value associated with inconclusive, which is 0.3, and so you get 1/3 of a point about for each one of these, the 61 times out of 100, and so we multiply those together, and that's the utility that's associated with the inconclusive responses. And if we sum these three things up, we get the overall utility for the mated prints for the SOP1 and the SOP2. Now, the units of these are the same units as up here, so you can think of them as points or whatever the units are up here. And the higher numbers are better. Things that are closer to positive infinity are better. So here we have a higher overall utility for at least mated prints for SOP2. So based on this, we would favor the SOP2, which allows inconclusives. Let's look at non-mated prints for a moment here. We can see that 35 times out of 100 here, subjects in condition 1 made an erroneous identification. That's very bad. Each one of those is worth -10 points, so here's the overall utility for that. Notice utilities don't have to go between -1 and 1 or 0 and 1. They can be anything they want. We have 65 times out of 100 they made a correct decision, because these are non-mated prints and they said exclusion. Each one of those is worth ½ a point, so here's the overall utility for that. So when we sum these things up, we get an overall utility of -3.2. We'll do the same thing for SOP2, which allows inconclusives, and we get a slightly larger, at least closer to positive infinity, overall utility here. And so based on this, we would also favor SOP2. Now, to compute the overall policy values for each of these two, we're going to do a weighted sum between this utility and this utility, and we're going to weight it by this probability of having a mated print. And the reason we do this is that suppose that you hardly ever got mated prints. Well, we wouldn't really care if there was a big difference between these two policies for an event that hardly ever occurred. So we want to sort of weight the utilities by how often you are to get a mated print, or in this case a non-mated print. And so we'll simply do a weighted sum here. Here's the formula for the weighted sum, just weighting it by this likelihood of observing a mated print. And now we can compute the overall policy value associated with the SOP1, which is not allowing inconclusives, versus SOP2. And we can see that SOP2 once again has a higher overall utility, the overall policy value, that would suggest that based on these values that we observe from society and the data that we observe from our participants, that we should get this particular, we would prefer the SOP2 that allows inconclusives, because it provides a greater overall value to society based on our values here. Now the next step here would be to start adjusting some of these values, like maybe the correct identifications here should be -100, if you believe Benjamin Franklin. Well, you can see that changed the scale of these two, but we would still prefer SOP2, even more so now, actually, in this particular situation. Let's put this back to -10, and let's say that inconclusives are bad, so let's give them a -0.5, for example. Well, we would still favor allowing inconclusives here. So there may be a wide range of sets of values that would allow inconclusive, but we would have to explore that space. we can also come in here and we can paste the data from the set size 8 condition to ask whether you should have a different set of values for trials that are easy versus hard. And so if I paste this right here, paste special, we get the values. Whoops, that didn't work at all. And now it looks like there's a difference between the two, but it's not as extreme as it was before. This will probably make it a little bit more extreme there. So that's how we go through and choose different values here to decide which of these two policies we would prefer. And my guess is that there are going to be many, many sets of values here for which you would prefer the inconclusive rather than not preferring it. But that's something that we can explore.